Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the creation of clickable buttons on a graphics window. We have created a number of videos which cover the creation of dialogues in the PowerBasic Windows compiler. These dialogues allow you to create objects on screen that users can click on. And additionally, the Windows compiler provides you with an event handler, a series of callback functions, in which you can handle the events that have occurred when users interact with this dialogue. This functionality is not available within the PowerBasic console compiler, mainly because the console compiler is designed to operate with console applications, which do not require dialogues. However, what happens if all you have is the console compiler and you need to provide some kind of user feedback or user interaction with a pseudo dialogue on screen? Say for example we'd set ourselves the task of providing to the user a button to click on from within the console compiler. How would we do this? Well, today we're going to be using a graphics window. This application can run either within the Windows compiler or the console compiler. But we're going to be using a graphics window, and on that graphics window we're going to provide a clickable button. And the code behind is going to detect that the button has been clicked. So let's have a look at the code. Our first task within the application is to create our graphics window. So we're going to be using the graphic window command, setting the title to mouse click and setting its coordinates, its width and height on the screen. The output from this call is to populate a variable, in this case a D word. This being the handle of the graphics window itself, so we'll need to declare a local variable to hold that information. Next we want to tell PowerBasic that this is the active graphics window, and we want to use the redraw option to ensure that the graphics are only redrawn to the user on screen at a point in the code where we wish to do so. So we can use the handle we've just populated, hwin, and we can mark that as graphic attach with the redraw option. We may want to send some text to the screen, so we're going to set up a font to do that. So we'll use the font new command and we'll pick Courier New as the font of our choice. And we're going to be using a 24-bit font, so it's quite visible on screen. And that gets populated to a DW font variable, which we've also declared. We now want to instruct PowerBasic to set that font as the current graphics font so that any text automatically picks that up. And we're going to use the graphic clear command to clear the graphics window and give it a background of light grey. So to complete this section, we will print the words click button when ready to the top of the graphics window, and we will execute the redraw command to redraw that to the user. If we try running our code now, we will see we have two windows on the screen, a standard console window, which we're going to be using to display information, and a graphics window, which has the words click button when ready at the top. So to terminate the application, we will close the graphics window, and then we will exit the console window. So now that our graphics window is prepared, how can we display a button on the screen? One of the things you can do within a graphics window is you can render graphics to it. So we're going to create a bitmap, which is going to be the image of our button, and we're going to render that on the graphics window. So we have created a bitmap graphic called clickme.bmp. If we have a look at that, it's a simple rectangle with the words click me on it. This is going to be the image we will render onto our graphics window, which will become our button. So how do we render that onto the screen? Well, we'll need to define in a variable the path to and the name of our bitmap. So we declared a local variable called bmp name, and we're populating that with the clickme.bmp, which exists within our current folder. As the bitmap you're going to be rendering may be of different sizes, you want to determine the size of the bitmap at runtime. Therefore we can open the bitmap for binary handling, and we can get the information for the width and the height out of the bitmap file itself. We've used this technique in previous videos. So we're assigning the long file variable to be the next available free file. We're then opening our bitmap for binary handling as that file handle. And we're using two get commands. Firstly to get the width, and secondly to get the height of our bitmap. We can then close down the file. So we will declare those variables we've now started to use. The width, the height, and the handle for the bitmap file itself. So now that we've determined the size of our bitmap, we now have to decide where we want to position it on screen. We need to set the position of our button. So we will create two new variables, one called xGraphic and one called yGraphic. So we want to position the button 100 pixels in from the left hand side and 100 pixels down from the top of our graphics window. And we will define both of those variables at the top of our code. So now we come to the point where we can actually load our graphic up and render it to the graphics window. So having determined the size of our bitmap and where we want to place it on screen, how do we actually render that straight to the screen? Well, we use the graphic render command. The graphic render command takes a number of parameters, the first being the name and the path to the bitmap file on disk. Then the next set of parameters are in brackets. The x and y coordinates we want to start the bitmap at, and the x and y coordinates we want to end the bitmap at. This is why we picked up the width and the height. So if we try running that code now, you will see we now have the button on our graphics window. So now that we have the button on the graphics window, let's see if we can detect mouse clicks on the graphics window itself, because we'll need to know that the mouse has been clicked in order to know whether the button has been clicked. At this point in the code, you realise just how much work the dynamic dialog tools are doing for you in the Windows compiler. So now we have to create the basics of an event handler. This is basically a loop to capture mouse clicks. We're going to run round this loop and try and detect the mouse having been clicked. So we're going to do this every 100 milliseconds. And we need to detect whether the graphics window is actually still open or has it been closed by the user. We can use a straightforward isWindow command to determine whether the window handle, which we determined earlier when we created the graphics window, is still active or not. If it is no longer active, then we can exit this loop. So if the return from the isWindow function is false, then the graphics window has been closed and we can exit the loop. So if the graphics window is still open, we need to check to see whether the mouse has been clicked or not. And there's a graphic window click command we can use to determine that. So we're giving it the hwindow handle and we're giving it three additional variables, a click variable and an x and a y coordinate. If the click variable returns 0, then there has been no mouse click. If it returns 1, then the left mouse button has been clicked once. If it returns 2, then the left mouse button has been clicked twice. And the x and the y coordinates in pixels on the graphics screen are returned in the long x and the long y variables. So we'll need to declare these new variables at the top of our code. So now that we've done that, we can now test the value of our click. So if the value of long click is greater than 0, then the mouse has indeed been clicked on the graphics window. So for information purposes, let's pick up the value of the x and the y coordinates. And we're going to print those out to our console window. So let's run the code now and see what happens. There is our graphics window, and if we move the mouse somewhere inside the graphics window and click, we can see the coordinates are now appearing. So as we can determine the x and the y coordinates that have been clicked on, it should now be fairly easy to work out have we clicked on the button or not. After all, we know the location of the button, we know its width, and we know its height. So it's a simple matter of arithmetic to work out whether the x and y coordinates are within that boundary. So we're testing if long x is greater or equal to the original position of the x coordinate of the bitmap, and less than or equal to the x coordinate plus the width of the button. and also it's within the boundings of the Y coordinate. And we're going to print out to our console log button click if we've detected a click on the button. If we run that code now, we can click anywhere on the graphics screen and the coordinates are returned. If we click somewhere on the button, it is indeed picking up the fact it's a button click. So although we are now picking up the fact that the mouse has clicked over the button, there is no visual feedback from the button that you would normally get. When a button is pushed, it generally moves. So we need to animate our button slightly to give the illusion to the user that they've actually clicked on an actual button. So let's go back to the code. How can we simulate a button push? So what I'm going to do first of all is to set up the graphic line width. This is to make it slightly thicker so we can actually put a simulated shadow in place to indicate the fact the button has actually been depressed. So we will declare this new line width variable, and we're going to set its value to 2 pixels. Now I'm going to draw 2 lines, one along the top edge of the button and one down the left hand side of the button. And to do this, we're going to use the graphic line command. Graphic line will draw a line between 2 points. We've designated the first point as being the top left hand corner of our button. And the ending point is the X coordinate plus the width of the button. And we're setting the colour to be dim grey. And the second line is a vertical line. And at the end, we will do a graphic redraw to display this to the user. So having drawn this vertical and this horizontal line, we now want to re-render the bitmap to appear as if it's slightly to the right and slightly down, as if the button has changed aspect by being pushed in. So we can re-render the button graphic to our graphic window, moving it 2 pixels to the right and 2 pixels down, and making it slightly smaller than it was before by the same margin. If we run the code now, we will see when we click on the button, it appears to be depressed. However, it's not returning back up again like a button would normally do, so we'll have to simulate that again. And we can do that by simply re-rendering the graphic in its original location. However, we don't want to do it instantaneously, there needs to be a slight delay. So we're going to wait 100 or 200 milliseconds before we redraw. So the redraw command is in for the depression of the button. We're then going to wait 100 milliseconds and then re-render the graphic, going back up 2 pixels. And then using the graphic redraw command once more to redraw that graphic to the user so they may see it. So if we try running that code now, we get our graphics window, which is still detecting the clicking of the mouse, and if we click on the button, it will briefly depress as if the user has actually clicked on it. And after each depression, 100 milliseconds later, the button will return to the upright position. So what we've achieved today is we have created a graphics window. And on that graphics window, we have rendered a button from a bitmap file. We're detecting mouse clicks on the graphics window, and we're determining if the mouse click is over the button or not. If it is over the button, we are moving the graphic slightly to the right and down to simulate the button click image. And then 100 milliseconds later, we're returning the button to its original position by redrawing the graphic on the screen. This to a user will give the illusion that the button is in fact interactive. So using this technique, you can display buttons on a graphics window. And then once the user has clicked on them, once you've done the redrawing, you can then call any function within your application that you need to do. So it would be quite possible, although a bit of work, to create a graphics window with interactive controls. However, if you're going to be doing a lot of dialogue work, I would recommend doing as much as you can in the Windows compiler. But if you really need to, you can do some within the console compiler. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.